everybody, Stu, AG6AG, and today we're going to talk about stealth antennas. We're going to take a look at a quick little thing I did with a VHF antenna, and we're going to look at the first part of my HF antenna, my HF stealth antenna. This is what's called a terminated butterfly antenna, and it's actually, I'm going to put it up at my house and run tests against my dipole to see how well it works. So, hey, do me a favor, would you? If you like my videos and you want to see the updates to these, subscribe down at the bottom and then click on the little bell, and we'll send you an email when I come out with new stuff, okay? With that, let's get to it. Hi, everybody. Well, let's start out with something fairly easy. Let's start out with VHF, UHF antennas. Now, are they easy? Well, they're smaller, so they might be a little easier to hide. I know that a base antenna, a smaller base antenna for 2 meters and 440, comes in at about 4.5, 5 feet. So that's not necessarily small. However, you can get a 20-inch high quarter wave automotive antenna or vehicle antenna that is fairly easy to disguise. Now, let's take a look at one of the concepts that I had here. I have to tell you something funny, though. When I first decided to do a few videos on stealth antennas, I thought, gee, God, a bird feeder would be an excellent idea. I could hide all sorts of stuff in a bird feeder. And then I started reading complaints from HOAs or people that had HOAs, and one of the biggest things apparently HOAs don't want you to have is a bird feeder or anything to feed wild animals. They don't like wild animals. They think that it brings wild animals in and they destroy stuff and they wreck stuff and they poop and all that, and most HOAs apparently don't want that happening. So wildlife in an HOA is out of the question. But then I thought, all right, what could I use that might just possibly be able to get rid of varmints, and how could I use that to disguise an antenna? So I started poking around a little bit, and I came up with this idea. So this is a plastic owl. Let's call him Hoot. And Hoot scares varmints, scares small birds, scares, my goodness, it'll scare a raccoon, it'll scare a skunk, it'll scare a mouse, it'll scare a rabbit, scare a squirrel, and a lot of people use these in defense of stuff coming in and tearing up their yard and wildlife coming in. I could certainly figure out a way to put one of these up and justify it, right, to a HOA that, hey, I got critters in here and I want to get rid of them, and this seems to be working. Now, I will tell you, though, that the idea really behind this came down to being able to hide that 2-meter antenna in there, and that is nothing more than an automotive mag mount antenna. And hey, that little extension in the bottom allows me to stick him on there. I could put him on a little wood podium or something like that in the backyard, right? Carefully run the coax back behind it and paint it so it's the same color as the podium itself, so the coax really isn't detected. And I could probably get away with that for a while in my backyard. Might even be able to get away with it in my front yard, but that might be stretching it a little bit. Anyway, these were the kind of ideas I was looking for. So I wanted to show this to you because this is a quick and easy thing to do. It's cheap. I've got 2 pieces of PVC joiner kind of glued together on the bottom, and then I've got those screwed into the bottom of a plastic owl. And the plastic owl already had a hole in the center of it. I just was able to slip it right down over the top. And I tested it with an HT. It worked really well. Just as good as any portable mag mount you'd have out there. And And that's just with that little 1 foot square piece of sheet metal down at the bottom. So, hey, might be worth a try. But this was easy. I mean, I did this in a few hours. It wasn't hard, even coming up with the idea. But I really wanted to come up with something for HF, and that's where we're going to go next. Well, all right. Let's take a look at some ideas on stealth antennas for HF. This one actually came from a friend of mine that sent me a picture that just really intrigued me. I kind of buried it in the back of my mind. And about 2 years later, another friend asked me about stealth antennas. And that other friend, by the way, kind of inspired these stealth antenna videos. So let me go ahead and show you what this is all about here. This website right here, hflink.com, is a marvelous resource for wire antennas. It really has some really neat stuff. The guy that turned me on to this basically showed me this picture from the website. The broadband Butterfly Terminated Dipole Antenna. And the thing that caught my eye here is this thing is amazingly stealth. I mean, it basically is just running around the perimeter of the house. If you got white fascia boards or whatever, you can run white wire. I think that they'd really be hard pressed to turn around and ID this as an antenna. Now, I'm not telling you to go against your HOA here, but this might be a feasible solution for you to get on the air. Now, this antenna has a 1,000 ohm resistor on it, and it also has a Balun on it. That 1,000 ohm resistor, that's got to have enough resistance to handle whatever wattage you're going to try to transmit with, and that 16:1, the same thing. That's a 16:1 Balun. So you're probably going to need a tuner with this as well, so you need to take all those things into consideration before you take this up. By the way, the guy that sent this to me, I got to give him credit. The guy that originally showed this to me, KM6GUE, he's a really great guy named Jim that I've known for a little while now, and a very dedicated amateur radio operator. And a shout goes out to him for giving me this and allowing me to figure out a way to go ahead and deploy it and show it to you. All right? Now, what are the obstacles of this? Well, you need a 1,000 ohm resistor and you need a 16:1 Balun. Well, let's start with the 16:1 Balun. A little farther down the page, they have examples of 16:1 Baluns. They have this one, which is this guy, Mel Farah, came up with K6KBE, and this is the one that I actually build in the video. So I want you to kind of pay attention to this. It's a really simple design. It's basically 4 toroid sleeves or ferrite sleeves and some 18 gauge Teflon coated wire so it doesn't, melt. And that's it. It's very simple to make. And there's a little bit close illustration, of how he put it together. And I built one just like this, exactly like this. Put it inside of a piece of PVC, which I'll show you in a minute. This is another example of a 16:1. And of course, the ferrite cores here is to try to keep from getting common mode. This is basically kind of creating a 1-to-1 Balun. We'll talk about that as well in a little bit. But there are several different designs for this Balun. And of course, you don't have to use it around the house. You can stick this up in your backyard. It's a great experimental antenna to do. I think it's going to be a lot of fun. And I hope you enjoy the video on it, okay? Anyway, that's kind of a lead-in here for what I really want to show you. And let me pop back over here 1 second. And here is what we have, okay? We have There it is. That is the 16-to-1 Balun that I made from that four ferrite sleeve design, okay, with the Teflon wire. And the reason this is so big is I couldn't get caps any smaller at the builder's store out here because of all the garbage that's going on right now on stuff coming in from overseas. So I basically ended up making this probably twice as big as I needed to, just because that was the material I had to work with. So, but this actually is nothing more than four of those sleeved ferrites and some wire, a regular old UHF connector at the bottom, and two studs at the top. All right. Now, I wanted something to test this against, so I got one of these. Now, let's talk a little bit about this, because this is a pretty nice little unit, okay? I happen to like it a lot. This is made by Palomar. Palomar Engineering is a company out here in Southern California that we buy a lot of toroids and other ferrite products from. They have an amazingly good reputation on selling the best of the best in ferrite products. If they say it's a mix 31, it's a mix 31, and it behaves like a mix 31. You can get some toroids and some ferrite cores and other things that don't really behave the way they should, and that's basically because they're chintzy on the mix. Palomar, I've never had a toroid or any ferrite core, for that matter, that misbehaved and didn't act like it should for the mix it was supposed to be. Anyway, this little gem right here, it was kind of expensive, okay, but it is a 16-to-1, but bonus, it has a 1-to-1 built into it, so I don't have to worry about a 1-to-1 at the bottom of the 16-to-1. It's all in one box. That, and it's rated for 1,500 watts, okay, so I would be hard-pressed to burn this up. Not to say that I couldn't, because I'm good at doing stuff like that, but this works pretty well, and I actually wanted a commercially manufactured product to use my tiny VNA to test against. So that's what we're going to do now, is we're going to test these two items and take a look at how they compare from a technical standpoint. Hey everybody, so let me show you what I'm going to use to check these 16-to-1 Baluns with, all right? Let me go ahead and swing down here to my little test bench setup I got going here. Now, we're using my MiniVNA, okay? This is the MiniVNA Tiny. I've had this for a few years. I really like it. There's a lot of the nano VNAs out there with the LEDs and all that good stuff, but this one is pretty doggone accurate, and I will tell you that I've had excellent luck using their software. Now, with all that said, your mileage may vary, and you certainly can do everything I'm going to do today with a nano VNA, all right? So, we also have over here a 800 ohm resistor that we're going to use on the output side, or actually the antenna side of the Balun, and of course a cable right here that we're going to hook up our Balun with, okay? Now, let's see. I am going to go ahead over to the software here. Let's see. There we go. And this is the VNA/J software. It's a Java program, so it runs on just about anything. The nice part about this is it's fairly simple to get set up, configured, all that good stuff. Calibration, all that's really straightforward. And everything is done inside the software. You don't have to do anything trying to punch a little screen. The downside is you always have to have a computer to use this device. So I'm going to go ahead and I want to set my green line to what's going to be the actual resistance in ohms that it reads on the device. And let's see, I've got a scale for resistance of 1 to 100 or 0 to 100 ohms. That looks good to me. And over on this side, let's go ahead and let's take a look just at SWR and see if we are contributing to any kind of issues with reflection. And this scale is going to be 1 to 1 all the way up to 5 to 1. Okay? Let us go ahead and get our stuff hooked up. All right, so we got our setup over here. I got my Palomar Engineers Balun set up. This is sold as a manufactured product by Palomar. It is a 16 to 1 1500 watt Balun, and not only does it have 16 to 1 built into it up here, but back behind it, between that 16 to 1 and the coax, is a 1 to 1 Balun to get rid of common mode. Always remember, if you're doing a transform, like this is transforming 16 to 1, or a 4 to 1, or a 9 to 1, or whatever, it's not going to do anything about common mode. So we need to worry about that when we're setting up our antenna system. This has that 1 to 1 built into it to handle the common mode directly in the box. For those of you that have never heard of Palomar, Palomar, basically I discovered them when I went looking for ferrite toroids and cores and all sorts of other stuff, and they had an amazing reputation for the quality of their ferrite cores and toroids. And I will tell you that, you buy a Type 31 from them, a 31 mix, guess what? You get a 31 mix. You buy a 43, you get a 43. You buy a 61, you get a 61. So, great company. I can't say enough good things about them. I just wish they were cheaper. But that being said, this particular device here, I wanted to do a comparison against my homemade Balun, and it was worth the investment in this just to see how close I came. So with that, let's go ahead and test this thing. Let me change my screen here. Here we have my VNA software. Again, on the left, we're set for resistance, and on the right here, we're set for SWR. This Balun is rated from 1.8 to 31 megahertz, and that is what I'm going to run, is 1.8 to 31 megahertz. Let's go ahead and take a look at it. I'm just bursting with anticipation. Well, will you look at that? Okay. So right here in the dead center, that is 50 megahertz. Wow. You know what? That's pretty good. My low side right here looks to be 41 ohms. My high side over here looks to be 57, 58 ohms. And look at my SWR. It's kind of hard to tell on this scale, but back at entry point here, when I start to hit the frequency of interest, I'm down here at right about, let's see, let me get on it. There we are. I'm there with a 1.37 to 1, and the high side of this thing within that range, my goodness, 1.58. This thing's amazing. So you know what I'm going to do is I'm going to save this as a reference so I can compare this against the one that I made in real time. So let's go ahead and select export on this. I'm going to export an XML, and I'm going to call that the Palomar. There we go. And let's go ahead and go back and switch it out. All right, so there we are. There we are with my little homemade Balun here. And little story, the reason this is as big as it is, because it's huge, right? Is because I could not locate caps for PVC any smaller than this until I got down to about 1 inch, and 1 inch was just too small. I ended up being stuck with these. I think it's 2.5 inch pipe. I don't need it to be this big, but hey, that's what I ended up with because that's what I could get parts for. So another issue with making this homemade stuff, right? So let's go ahead and let's run a test on this. And oh, by the way, we do not have a 1-to-1 Balun on the back of this. Now, a 1-to-1 Balun actually should not affect anything as far as what we normally look at in the tests that we're doing. I'm going to go ahead and let me go ahead and fire this off. We'll do the same test with the same settings, and away we go. And we're going to wait for it to complete and see what it looks like. Wow. Well, there we go. This actually looks really good. For a homemade Balun, it looks amazing. Let me go ahead and save this sample. And this will be my homemade, right? All right, so let's go ahead and do a comparison. All right, so let's go ahead and analyze the two of these. Okay, so we'll, can I make this bigger? I think I can. Let's see. All right, let's shoot for about this size. Now, I'm going to go ahead and I'm going to load on the left side. Let's load the Palomar. And on the right side, let's load mine. And let's go ahead and we'll do a comparison. We can compare one thing at a time. So let's compare the ohms. Let's see, where is it? There we go. All right, well, the blue one is mine. And I have to, the scales sure match. So up here is about 50 ohms across the top. Down here is 41. Mine drops quite a bit lower when you start getting up about 22, 25 in there, where this one climbs. So they've got a little bit more of an S going here. But remember, the top of this is 58 ohms. The bottom of it is looks to be 37. So there's not a huge difference here. Let's take a quick glance at the SWR and see if there's any real change between that. Well, I'll be. That's pretty close. All right, so let's be realistic here, right? These actually look really, really close. Let's pull up the two Smith charts here on them. This is the Palomar, and this is the homemade. I have to tell you, that looks pretty good. So, all right, well, I would feel comfortable actually using the homemade. I have to get a 1-to-1 back behind it. Full disclosure also, though, I mean, the Palomar really was only about twice the price of building my own. Okay, and by the time I get a 1-to-1 sitting in there behind it and get that done, I'm probably going to be, a little more, well, no, I'm probably going to be about 2/3 of the price of that Palomar to build my own. How much wattage will mine handle? Well, I'm guessing I could probably get maybe 1,000 watts out of it the way it's built inside. But that said, you know, I'm getting 1,500 watts out of that Palomar. And the Palomar is a lot more compact little case. I'm going to have a bunch of stuff hanging off the one I build. Sure, I can try to get it all in there tight, but hey, I honestly think my mileage is better on the Palomar. Uh, just for the incredible amount of time I had to spend building the thing as well and getting it all the holes drilled and everything else and all the little parts that you need to make your own Balun work. All that said, hey, you be the judge. You decide which one you want to buy. And with that, that's the end of this portion. Let me go ahead and next up, I think we're going to try to take a look at some of the resistor packs that we made for the terminating ends of this butterfly dipole. All right, well, hey, we figured out the Balun. We have a 16-to-1 now. We tested it. We know it works. Whether we made it, we bought it, it really doesn't matter. We're ready with our Balun. So the next thing we've got to figure out is that terminating resistor on the far side of this antenna, right? We've got equal length wires going out that are going to tie together, and where they tie together, we have to come up with 1,000 ohm resistor. And that resistor is going to have to be able to take the kind of power that we're going to put into it with our radio. So, just mathematically speaking, you probably are going to need, I'm going to say, if you're going to run 100 watts, you're probably going to need a couple 100-watt resistor. And that isn't always easy to do, especially, the resistors that you see in other places to purchase. I mean, my gosh, half watt, quarter watt. So how do you build that up? Now, we all know that we're not really supposed to use wire wound resistors, right? Because they can become inductive and they can do all sorts of crazy things to the impedance. So we need to be careful with that. I did some experiments initially because, of course, wire wound resistors are a bit cheaper. Let me show you my wire wound resistor solution. You might get a bit of a laugh out of it. Couple people laughed at me, but yeah, I'm used to that. Let me go ahead and sneak on down here, and there you go. So this little piece of metal here, okay, is extending about 14 inches end to end to get all this stuff in this direction. It's got a 90-degree bend up here. Let me get this out of the way. I've got a hook up on the back here to connect my wires to. The concept was I've got this bend here, and I can drill holes in that, and I can use that to mount it under the roof on maybe one of the fascia boards, or maybe on one of the joists, right? And just screw it in there where it won't be affected. Now, these are wire wound resistors. They are 100-watt, 100-ohm resistors. Okay, so what you see here is you see 10 of them in series. And these are supposed to be non-inductive wire wound resistors. They're supposed to be wound in a way that they're not going to be inductive. But realistically, I don't know. And the only way I guess I could tell is to, hook something up and see if it goes crazy. And I'm not ready to do that yet. I won't be able to do it until I get some wire in the air someplace. But I completed this because I started it and I just wanted to see it to its fulfillment. So in order to get 1,000 ohms, we've got 10 of these things. So, and, they're 100-watt resistors. So theoretically, we have 1,000-watt capacity here. But my bet is, these I got on Amazon. They're probably manufactured, with very poor tolerances. Although, when I ohm it out, it is 1,000 ohms. So we'll give it a try, but this may not be what I end up with. Let me show you the other solution, which I like a little bit better. But what I have here is some heat sinks and some copper, and I mounted these on it. These are actually 100 ohm, 1,000 ohm, 100 watt resistors. And what I've done is I've taken two in series, right? These two in series and these two in series, and I've ran them in parallel in order to provide, at the end of the day, in order to provide me with 400 watts, okay, at 1,000 ohms. Better quality, definitely better quality. These are also not wire wound, right? So I'm not going to have any issue with inductance or capacitance or anything like that with them reacting from each other. I believe that I have enough heat sinks hooked on this. It's all put together with, conductive paste and everything else, So it's got the thermal conductive paste on all the components. We'll see how it works. Anyway, I got these on Mouser, okay? Mouser.com. If you're looking for electronic components, they have a pretty good selection. And then, of course, the other resistors I got over at Amazon. And again, your mileage may vary on all this stuff, but these came out pretty well. Obviously, more money in these, okay, than there was in the Amazon ones. But you know what? By the time I was done building out that platform, I spent a lot more money in that sheet metal piece than I did here. So, hey, you got to make something. Make the best thing you can and give it a try. All right? Anyway, gosh, with that, that kind of drops us right back into what do we need to look at next? Well, I think we need to look at how we're going to be running the wires, and that will be coming up next. Well, there you have it. VHF, UHF antenna in an owl. Hey, why not? Worth a try. And you got to see the first half of the stuff that we have to do to make that butterfly terminated antenna. The second half is going to be a little bit more, how should I put it, aerial. I'm going to have to get up on a couple ladders and throw some stuff over the roof of the house and some other stuff. But with that, I should have a really neat stealth antenna up in the air and something to test and show you my results against a real antenna. So, may not be the next video. I may sneak another one in because I got to wait for good weather. But as far as that goes, trust me, it will happen. Keep an eye out on the channel. And again, I don't live in an HOA, and if you do, my heart goes out to you. It's hard to be a ham when nobody understands what you're doing. So that's one of the reasons that if you're not involved with emergency communication, and if you're not involved in doing community events and letting people see what you do and talking about what you do when it comes to them. And let's face it, nobody wants to listen to us talk about what we do. But they're interested in what we do that's going to help them and why we're important. And you know what? We are important as amateur radio operators when the chips are down. Anyway, hey, if you like the video, give me a thumbs up down there. Let me know. If you have any questions or comments, make them down below as well. And of course, please, go ahead and subscribe to my channel. All right? Anyway, with that, I'm Stu, AG6AG, 73, and hope to hear you on the air.